All right, here we go. Okay, here we go. Test review today. Next class is the actual test. You are allowed up to 1 page of your own notes for this test, but you make up your own notes. So that means you take a piece of paper, you write down what you think is most important for this test, and then bring it next week, bring it next class. All right, so that's our game plan. Questions? Okay, are we ready? Dennis?
Yeah.
Okay, just making sure we're looking this way. All right, here we go. Number 1, regarding whether or not a proportion is true or false. There we go. Whether or not this proportion is true or false, who can tell us how we can figure it out?
Cross multiply.
Very good. He's right. Cross multiply. 12 times 4. This is not working nearly as well as I had anticipated. We'll start again.
48. And the other one is. Wait, I gotta mix up. Not proportional is when they don't match, right?
Right.
So it's not proportional.
Okay, why not?
Because it doesn't match. Right?
What doesn't match?
The sum of the cross multiple things.
Okay. Well, what's 12 times 4?
That's 40. No, that's 72. Wait, no, that's 48. That's 48. I gotta mix up.
And then 3 times 24?
72.
Yeah, they don't match. So, not proportional. If you write false, no.
They're really not proportional.
That's fine. Not a proportion. I'm okay with that. Okay. Number 2. I talked about it briefly on a board over here. This one you really have to be careful. Anytime you have a proportion with an expression, you need to put parentheses around that expression. And then you do your cross multiplying. I'll rewrite it so you all can see it better. (24/v+1 = 4/8). Let's do our diagonal multiplication. 24 times 8. So 24 times 8, what is it? How much?
192.
Good. Now, there's 4 times v+1. What up? Well, 2 things. What property is taking place here? Get into the D.
Wait, say it again. Repeat the question.
What property? 4 times v+1. What do we have to do to the 4 with both the v and the 1? Nope. Distribute. Got the right letter, but distribute. So when we distribute, what operation?
Multiply.
Multiply. So what's 4 times v? This is 4v. And then what's 4 times 1? 4. Now, are we at a point where we can solve for the v? Yeah. Can we solve for v at this point? Yeah or no? 4v plus 4 equals 192. Can we solve for v? You can. Why don't you try it real quick? It only take you about a minute. All right, what did we get for value of v? Anybody get that value of v yet? What'd you get, Noah?
47.
Do we agree? 47? Toranzito agrees. Joe? Nando, do you agree? Front row, do we agree? All right. Oh, here it is. Minus 4. One big. 188. Divided by 4. And then, there you go, V47. Good. Okay, questions so far? Remember, there's a chance you might see one of these on your test. So you beware. You might see this again very soon. All right. Next problem. So, well, this was from the very beginning of Unit 5, 5152. This next one, very recent. How about last lesson? Our last lesson involved a problem doing exactly what we're doing here. Now, here's our triangle.
So going circle 10, C50.
Say again?
Going circle the 10, C50. Or B4A.
Okay, I see what you mean.
For the whole thing.
Like this?
Uh-huh.
All right. You talking about like that?
Mm-hmm.
Okay, that's going to help you. Because here's what's going to happen. Cindy's got a right idea. Well, we can kind of, from this diagram, help us set up our proportion. So what would be in our first ratio? What number can we put on the top of the first ratio? Okay. What's going to go right underneath the 10? In your head, look at your diagram.
15.
That's 15. That's right, Norcus. That's one part of your diagram. Now, what about the second part? What are we going to put on top?
1.
Okay? Now, we don't know what VD is, so what can we do? If we don't know something, what can we use?
Variable.
Variable X. Now, are we at a position to where we can solve for this variable?
Yes.
Try it. This is where you do your diagonal multiplication. And if we wrote it this way, are these two expressions or equations the same?
Yeah.
They are. You're right. So either or. You're still gonna get the same diagonal multiplication products, and the value for x will be the same. So try that real quick, give me a minute. The number one part is getting your setup. Okay. So give me this on the preview. Okay, so we're on the next page. Over here. Anything you missed from beginning? Take from Nate. Okay. So do we have a value of x or value of BD? Anybody get it? Anybody get that value? I hear 6. Agree or disagree? You're not sure how? Tell us. If 6 is the correct answer.
So I don't understand how you take out the variable and put in a different number.
Okay, what do you mean?
Like, I don't know how you switch the variable or like the variable.
Okay, first thing we do, Dennis,
Yeah.
look out this way. First, you do our diagonal multiplication.
Yeah.
So, now it doesn't matter
Okay.
which one. If you use top or bottom, it's not going to matter because in the end, 4 times 15 or 15 times 4, you get it here or there. That's 60, that's the first part. Then you did it here, 10 times x or x times 10, you still get the 10x. Now, what do we do next? We want to get x by itself. What do we have to do with that 10? Add, subtract, multiply, divide, divide. We're going to be doing plenty of problems of this type all day today. And all day next class being your tests. So you really need to understand, well, the name of the game is getting here.
Is the test is gonna be on problems like this?
Yeah.
The whole thing?
Huh?
The whole test?
Almost. You can say at least 75%, maybe more.
Okay.
But this is no. But the goal is you got to get from the diagram to here.
No, I just didn't understand how you like get a number from coming from there.
Well, I mean, what? So like, I'm still trying to understand your
Yeah,
question.
I don't know like how you got 6. Is what I'm saying.
Well, that's what we did. Diagonal multiplication. And then you do the opposite of multiplying by 10, you divide by 10.
Alright.
It's, once you do your cross multiplying, then it's a matter of dividing, basically. That's all you're doing. Okay, questions before we continue? Okay, the next 2 problems are going to be 2 of the few where you may not have to worry about diagonal, proportion, multiplication, all that business. It's a matching game. And we play the matching game, well, for this type of problem, you get the similarity statements. What did I tell everybody to do with the first set of letters? Where can you write these first set of letters in relationship to the second set of letters?
On top.
That's one way you can do it. That's right, Steve. Now, could I have also written these 3 letters on the bottom, underneath the JKL? Sure, she's right. Now, you're like, it's real easy. Now it's just a match. It's a matching game. So there's your little trick. Now we figure out Okay, angle X matches with what angle?
Okay.
Who else? Who else is gonna match up
A.
with?
Y.
Good. And?
Z with L.
Bingo. Because there's gonna be problems down the road where you get the similarity statement, but you're gonna need to figure out who matches with who. That's why we have to identify.
That's easy.
Yeah, no, it is. We're gonna try to make it so as easy as possible. All right, ready? Any questions on this one before we go to the next problem? The next problem is going to be similar to this problem. The only difference is, rather than angles, we need to match our, besides angles, we also have,
Sides.
yes sir, sides. The same thing. JKL over XYZ, there you go. I'll give you a moment to figure out which sides match up with which other sides. Okay, we need that, Dennis. Come on. Give me a moment to figure out who matches with who.
Oh. J, X, K, Y, and L, Z.
Wait a minute.
Oh, no, it's putting that way. Never mind.
Yeah, because you know why I know where you're getting your for the angles.
I didn't see how it was put in this.
Yeah, because now with the sides you need two letters. So X Y, what side's gonna match with X Y?
Okay.
So boom, boom. What else?
Then Y is C. No,
X, Z is J, L.
X Z and J L.
And Y, Z, and K, L.
Mm-hmm. There you go. Again, take your similarity statement. Similarity statement is going to be key for these types of problems. Remember, we're going to see this on your test. Very similar problems. And this is good. This is going to be good down the road, not only for tests, but towards the end of the year, it will be fine. All right, questions before we go to the next problem? Because again, we need to understand which sides or angles match with which other sides or angles. Because when we do some other problems, like finding out either a missing value to see whether or not two triangles are or polygons are similar, or whether or not they are similar or not, you need to understand which sides match with which other sides, or which angles match with which other angles. All right, this is the next one. Now we're going back to our diagonal multiplication. You may not need to do that. Well, we need to figure out whether or not these two polygons are similar. There's a few ways you can figure out whether these two polygons are similar. I'll let you think about it. Who could tell us what we could do to figure out whether these two polygons are similar? What do you mean?
Oh, it's like the thing to the most point.
Okay.
75 and then put the other 5, bottom, then put 2 in the top, then 2 in the bottom.
So, you mean something like,
Yes,
okay. You said what, so what number was going on the top again?
15,
Uh-huh,
then 2,
okay,
then 75, then 5.
all right. And yeah, so you two were both on, so, yeah, you can figure out with the sides, like who matches with who. And then you set up your proportion, just like what you said. So, Melanie and Cindy, you were both right. And then, what's our next step? What must we do? Somebody had said it earlier. We need to
Cross multiply.
cross multiply. Yeah. 15. Five.
We're trying to find out if it's like proportional or not.
Exactly. Or similar. Basically, yeah. Similarity comes from whether or not you have a proportion.
Just by looking at this and I can figure it proportional.
We'll do our multiplication. Let's figure it out. Check your multiplying.
No, it's not proportional.
Nowhere near. And even if you just did a straight up division, 15 divided by 2, 75 divided by 5, that's not going to work. Absolutely not. But proportion will definitely prove it. So, absolutely not similar. Anybody have questions? Questions on this problem before we go to the next one? All right. Here we go. Good night. Here we go to the next problem. Does it work?
Are these graded notes now?
These are not. Last class were graded. All right, this one. Well, first off, rather than triangles, what type of shape do we have here?
Square.
Close. Begins with a P.
Parallelogram.
Parallelogram. All right. Now, unlike before, we need to figure out what the value of x is. Now, who could tell us how we could set up our proportion for this type of problem?
70, what is it then? X, 75 over X, and 85 over 34.
Okay, you said 75 over x and 85 over 34?
Yeah. Can you do it like that?
You can actually do that. That's one way, because here's what happened. Dennis, that's actually a good setup, because I'll tell you why. What he did was, he took the two shorter sides. Now, this is not the only way you can set it up, but this is a good setup. Long side. And then it was larger parallelogram, smaller parallelogram. That's a valid setup. Is that the only setup?
No.
No. What's another way we can set it up? And again, what you did is right. Just want us to see there's more than one way we can set up this proportion. Anybody else have an idea on how to set up this proportion? But what you did was 100% correct, okay? You didn't do anything wrong. Anybody else want to take a shot how we can set up this proportion? No takers? I mean, that's okay. You know the way you could do it? We do 75 over 85. And then x over 34. Would that still work? Could that way still work too? Yeah. I mean, again, what you did was right. So I don't want to take away from what you did because what you did was perfect. So you did a very good job. Now, are we at a point where we can solve for the x?
Yeah.
All right, I want you all to do it. I'm going to rewrite this. So this is one way, that's another way, but it doesn't matter how you set it up. You will get the same value for x. So I want you all to do that. Come on. No problem. Come on. So let's alter this proportion. We've already done plenty of these. The only thing I'm going to say is you do diagonals. It's the last I'm going to tell you. The first step, because going forward, we should know this first step. You should know this by heart going forward, because come Tuesday, I'm not going to be able to tell you I'm not going to be able to tell you how to solve for this proportion. So, good. Good. What you getting on? Good. Good job, Ed Sully.
Yeah, a few more.
Doing the right track. Keep going. You're almost there. Hey.
La abuela de Puerto Rico. Huh?
All right, how we doing with this?
Done?
Okay, come on.
Oh,
Seguimos trabajando. Keep working. Also, remember,
mister. So you multiply, right?
you gotta multiply diagonally. 85 times x, 75 times 34. That's necessary. That's required.
I got an answer, but I don't know if it's right because I'm still trying to get it.
Okay. What do you think you get? What'd you get?
X equals 30.
Agree or disagree with the 30?
Agree.
That's right. It is 30. Very good. 75 times 34 was 2550. And we have to divide both sides by 85.
It's so easy.
Once you get the setup and the practice, the name of the game is going diagram to setup.
It's easy, but it's still
But it means practice. We have to keep practicing. Seguimos practicando todas las oportunidades. Every opportunity. Keep practicing.
Well, I don't understand
Okay.
how to solve.
Okay. So once you get the setup, do your diagonal cross multiplication. And then once you get your cross multiplication, remember you want to get rid of, you want this x by itself.
How do you get a number for the x?
That's when we divide because you have the other number, right? Divide both sides by this number. X is by itself. Divide these two numbers.
Oh, so you put the number that doesn't have a number, you know, so 85 times
The x. Because remember,
x.
yeah, these, if it's a number times a variable, it's just the number of a variable. That's it. It just comes on down by the line.
Well, then we put the answer.
Well, you have to divide. Once you get this part, then you divide by this number here. That's how you get that answer. So it's basically you multiply twice, you divide once, yeah, that's it. We're gonna practice this a few more times. Don't worry. You get plenty of opportunities. All right.
No, because we're taking time to learn.
Next class,
Oh, wait,
what?
it's on Monday, right?
Tuesday.
Monday
Oh,
we
there's no
have
school on
school.
Monday.
Yeah, you don't. Yeah, I know you didn't want it on Monday. All right, here we go with the next one. Okay, what's gonna happen? A flag, standard flag, 2 feet by 3 feet. But now, we're gonna have another flag that's similar to the standard size flag. Now, what I tell everybody to do, might be a good idea, draw a diagram. The first flag was 2 by 3, right? They said the shorter side was 2, the longer side was 3. We agree. That's from the first sentence. So, first sentence, there's your diagram. Now, second sentence tells us big flag. But what do we know about the big giant flag? What do we know about the big giant flag?
It's the short side is 18.
Okay, so where's the short side going? Here or there?
Up and down.
All right. We know the length of the long side?
And it's Merrick's.
It's an X. So second sentence is just this diagram.
Set this one up.
So let's figure out how we can.
18 over 2.
Okay.
X over 3.
You can do it that way. That's one way. So he went short side, long side. I mean, giant flag, standard flag. That's one way you could set this up. Is that the only way you could set it up?
There's another way.
Okay, what could be another way?
2 over 3 and 18 over X.
2 over 3? 18. That's okay too. That's good too because he went short side.
It's the same.
In the end, you're going to get the same value. Yeah. So we're just saying there's more than one way you can set up a correct proportion. So that small flag, giant flag. So yeah, you can set them up. Those are multiple ways we can set up this proportion correctly. Now, are we in a position to solve for the length of this flag?
Yeah.
All right, let's do it. So yeah, both ways would work. Let me. small flag, giant, or standard flag, giant flag. Yeah. So again, good job getting those setups. You'll get the same value of X both ways. So I want you all to try it. A lot of it is the setup. Get it? All right. Got it? No, you get it? Okay. All right. We'll find out. Don't tell anybody. Okay. You can tell us what's our value?
X equals 27.
Instead, X is 27. Yes, no? Agree? Okay. Okay. 18 times 3. 2 times X. 2X. 54. And then X. 27. All right, questions? Okay. All right, next two problems. The key is, anytime we have, I don't want to mess up Ms. Edwards' work. Anytime we have these bow tie looking diagrams, what do we know about these angles here? What do we know about those type of angles? Just specifically the two angles that were marked in that diagram.
Congruent.
They are congruent. Who could tell us why angles, like those two particular angles, who remembers the reason why those angles are congruent? Hold on, listen up. I think we want to hear what Joey has to say. They're vertical angles. Because, so ladies, listen up. These two angles are going to be congruent because of vertical angles. That's going to help us because when we do these types of problems, again, with these similarity rules, what is going to matter? Because anytime you have the bow tie looking diagrams, I call it a bow tie because it looked like a bow ties from back in the day, like with tuxedos or whatever. With them bow ties, your vertical angles are congruent to each other. Well, in this case, it's just angle because here, I mean, if the sides were marked, then yeah, would have been angle, side angle. But for similarity purposes, all you need to know is angle, side, side. What's going to happen? Your triangles are going to get marked. So it's for these types of problems, you just need to know what type of similarity setup you have. You angle. That's what we have going on here. Anybody have any questions? Any questions on this setup here? So you don't necessarily, the order will help us, but we don't necessarily need the order. And the next one's going to be a similar situation. Because here, again, in order for triangles to be similar, all you need are just two angles from one triangle to be congruent to two angles of the
Be
other.
on the test.
Huh?
Is that gonna be on the test?
Oh yeah, you're gonna get a couple like this. And then again, look at what's given to you. And then next one's gonna be the same idea. Let you know when we're ready. Next one, same idea. Okay, Norcas, you ready? All right. This one, similar to the other problem. What type of figure do we have? A bow tie. So therefore, what do we know about this angle and that angle? Vertical angles, that means they are congruent. All right, now, this one's going to be super easy. So, basically, what's marked on these two triangles? We definitely have how many sides? Well, per triangle. Look at each triangle separately. Okay, you got a side, side.
Side.
Ah, careful.
Side angle side. In the middle there's a side.
There's the angle right here.
Oh, side angle side.
It's going to be a side angle side because this last side we don't know. We don't know that yet. You have to be careful. If you were given all three, then it would work. Now, right here, you're just given the two sides, but the angle in the middle, since they're vertical angles, that's when you can automatically say you got side angle side. Now, the only thing I want to ask, let's say if you had to determine if these two triangles were proportional. You don't have to, but I just want you to be careful with the order. Because right here, R and Q, M and L. Just watch your sides. Because with the first triangle, you could have went 56 over 48. And you don't have to do this, but for the second triangle, is it going to be 60 over 70 or 70 over 60? Where's your agenda? Who can tell us? Is it 60 over 70 or 70 over 60? 70 over 60, yes. Good. Okay. Notes will be posted later today along with a recording. Right. So yeah, do be careful. Yep. Oh, escort. Escort. So, you know, she already signed the agenda, so.
Oh. Did you sign it?
Yeah, I just did. Thank you, Ms. Ahmed.
That's yours.
Okay. All right, here we go. So good job. We already knew. You gotta match the larger side and the smaller side on the bottom. Larger side top, smaller side bottom. Good job. You didn't have to do it, but it was good for us to know. All right, here we go. Now, the next couple problems I think might be the most difficult on the next page. We did this last time. But I think if you get these types of problems, you got the whole thing. You will be able to do this. All right, now, here's what we're going to do. Right away, this type of diagram. What type of, do we have a right or left slant for this triangle? Or left slope, right slope? What's the X represent? That's left slope. Now, what we do is the following. Our first ratio, you get right here. So there's your first ratio. X over 9. Now, what do we know goes here?
7.
Mm.
Wait, X, wait, no.
9, 7.
Okay, hold on. From last time, anytime we had the left slant or right slant, where do we copy this X? We copy it on the top or the bottom?
Wow.
Bottom, very good. You gotta copy this. Boom, down there. So that's your set. So that's most of the setup. Now the last part. What goes here? Not 7. Something else goes there. Not 7, but well, what do we have to do with our two bases? Anybody remember?
Oh, 9 plus 7.
9 plus 7. That's right, Noe. Good job. This goes up here. But what is 9 plus 7?
16.
Here's your proportion. Here's your proportion. So right away, left. It would be similar for the right slant. If the X was on the right, then it would be X over 7. But right away, this part right here, there's your first ratio right there. Then you recopy the X, put it there. The last part, you just add your base. Sorry about that. Now, are we at a point where we can solve for this proportion? Right, I want you all to try it. Solve for this proportion. Give it a second. Let's try to solve for this proportion. Let's try to solve for this proportion. We're gonna go so. I'm gonna tell you what you have to do for the last step. Now remember the last step. Be careful. Be careful with the last step. It's Remember, what's that? Does anybody remember what x times x is? X times x. Anybody remember? X times x. Give you a hint, it's not 2x. All right, I think this one we'll talk about. Here we go. This one you may want to write somewhere. All right, we're ready. Estamos listos. Okay, here's what's going to happen. You might want to see this part, because I know you missed last class. This part, we're good. 9 times 16 is how much? Okay. This part, we haven't seen in a while. What's x times x? X squared. That's x squared. Quite a few of us wrote 2x. So good. Now, what did we do to get from x squared to x? 2 words. Square. The other word begins square root. Very good. No, he's right. You got to do a square root. Again, if you're not sure how to do it on the TI-84 calculator, let me know. Or I'll tell you. You hit the blue button, that second button, and x squared. So on a TI-84, second, x squared, and then type the number. And then enter. If you're using a regular blue calculator, type the number, then hit the square root button. So in the end, what would be the square root of 144? 12. Square root of 144? 12. So, for some of you, I know we're out last time. That's definitely one of those types of problems. I'll tell you more about that later. Okay, questions?
Mister, can I go to the bathroom?
Here's your agenda. Okay, go on and pass. Okay, questions? What have you missed? Get from the neighbor. All right. Anybody questions on this problem? We'll have a few more to go. And we're almost there. All right. Here we go. 12. Now, unlike 11, anybody remember what? Anybody remember what that line in the middle of the triangle was called? Anybody remember? Begins with an A.
A?
Begins with an A. Think about, all right, I'll give you a hint. High altitude. That's your altitude. Well, we just nicknamed it ALT. If you have a problem like this might be something you want to write down. Then there was altitude over base 1. Then, for the second half, did the altitude go on the top or on the bottom? Look at our proportion setup. Altitude. Do we keep it on the top for both? Where's the altitude going? Second, it has to go on the bottom. Same altitude goes on the bottom. Base 2 goes on the top. Now, will it matter how we order our bases? If we put base, if this is base 1 or this is base 2, wouldn't that matter in the end? No, it would not matter. Just as long as you know this X, the altitude, has to be crisscross. If you set that up, you put that altitude, that X, crisscross, you're going to get the problem right. Because these two numbers, it's not going to matter where you put those two numbers in the end. Because you have to multiply them either way. You get the same result. This is the most important part. You got to make sure your X, your altitude, because you might get a whole number at times, or any type of number. Your altitude, as long as your altitude is crisscross, then your bases, it don't matter. Then from there, you do your diagonal multiplication. Do your crisscross. So what would be 10 times 4.9? And then what's x times x? X times x is x squared. Now, you're probably thinking, oh, 49. Can we take the square root of 49? Can you take the square root of 49? Yeah, you can. It's actually much easier than you think. So, what would be our square root of 49? 7. That's right. There you go. That's 7. You will definitely get one of these on your test. I promise you will get one of these problems on your test. The one that we did before this one, you're either going to get a left slant or a right slant. But if you know what goes where, then everything else is going to fall right into place. Because the right slant will be similar to the left slant. And there's time I might show you a problem like that. But if there's time, let's see what happens. All right, questions before we go on. But these type of problems are easier because as long as you know whatever your altitude is here, put it there as well. And then those two numbers on the bottom, it don't matter where the other two numbers go. So that's the easy part about these types of problems. All right. Questions before we continue? We're almost done. We're close. All right, so let's look at the next. We're ready. Let's go to the next problem. Give you like 10 more seconds. And the next couple are actually going to be back to the stack and go deal. They're the easier ones. But they're easier than the two that we just did. I'm going to show you how they're much easier. Let me know when you're ready. Because the one before if you got the one before this problem, if you don't understand these two problems right here, I think these two are going to be the toughest problems on the whole test. But remember, the goal is left slant, crisscross. Similar case with a right slant. If there's time, we might do a quick right slant problem. Here, altitude, copy it, make sure it's crisscross. Those two bases, it don't matter where they go. And here's why these next problems, notice these next two are going to be easier. Think about just stack and go. This is really a stack and go problem because this type of problem, we have two parallel lines. Who thinks they have an idea on how we could set up this proportion?
2 over x and 6 over 9.
Say it again.
2 over x and 6 over 9.
It was that easy. There you go. It was that easy. It was that easy. Can we solve for x at this point?
Yeah.
Now that, I'll let you try it on your own. So I told you it was going to be that easy.
Yeah, got it.
Let's see. We'll find out. Let's wait. Let's wait. Give other people opportunity. Okay, you got it. Got it. Got it. All right, yeah, most of us got it. Anybody not sure how we got it? 'Cause I think going forward, we understand what's going on. We're going to go forward because the goal is connections, connections, connections. Because by now you should be professionals at solving these types of problems.
We're doing the same for the next one.
Next one, I want to talk to us real quick about, there are multiple ways we could set up this proportion.
So 8 over 20 y over 25.
That is a way. I'm not going to disagree at all. Is that the only way?
No.
Okay, tell us another way you could potentially set up the proportion. Okay. And what, 20 over 8 and what over what?
25 over 1.
That's okay. Any other way? So,
8 over y.
say again?
20 over 25 and 8 over y.
That's another way. Good. So, all three of these are appropriate. I mean, the other way you could have done it, 25 over 20, y over 8, that would work too. Now, are we at a point where we could solve? Yeah. Chéverísimo. All right. I'll have you all try it. So remember, 4, 4. Not bad. Remember, there's still one more problem. And then I might throw another one just for more familiarity.
That's right.
Yeah.
We can, it's just not.
Yeah, that's a different one. That's a way different one. Gracias. Yeah. Remember, we should be at least trying. It's on the test. You're gonna have to do the work. I'm not gonna be able to help. There's Sally. All right, that looks like good work there. Thank you.
Then she started talking about how I used to go work and she was
All right. Okay, Cindy. Let's finish this. Come on. We should be writing down the steps. Figuring out what we need to do. Okay. Focus on the math for now, please. Marcus, come on. Come on, let's get this work done. All right, what did we get?
10.
Good. Questions? Well, you had to multiply 25 times 8. That's what happened. Multiply 25 times 8. Oops, sorry. Yeah, I think you divided accidentally. Yeah, you gotta multiply. Okay. Here we go. Last one. All right. Heads up. Scale factor. Okay. Here's the important thing about scale factor, ladies and gentlemen. Hold on, we're not done yet. With the scale factor, order matters. So, scale factor, order. Now, ask yourself a couple questions. One, so we're going from EFD to FKJ. This direction. You getting larger or smaller? Are you going from smaller to bigger or bigger to smaller? We're getting larger. Actually, let me rephrase that question. So, are we getting larger or smaller? So, no, you were right, we're getting larger. Now, getting larger, is our scale factor going to be bigger or smaller than 1? If we're going from smaller to larger, it's going to get bigger, yeah. Because now we need to figure out. Now the goal is we need to figure out what number are we going to multiply any of these 3 sides by to get those 3 sides. Say it again. In the end, it's going to be 4. That's going to be your scale factor. And the way you get it, well, I told everybody, the order, do we keep it or do we flip our order for scale factor? So we put EFD would we put it above or below FKJ? What did I say about scale factor? Do we keep or flip our order? Anybody remember? Keep or flip? Listen. Do we keep this order or do we have to flip? Who remembers? We have to flip our order. So you would put F, K, J above EFD. The reason being, we want the bigger number on top, because when we divide the bigger number by the smaller number, will our number be bigger than 1? That's what we want to do. So for instance, F and K, 12. What's 12 divided by 3? That's why I tell everybody, with scale factor, flip that order. If you don't flip that order, you're going to get a number that's going to be less than 1, when you should be getting something bigger than 1. Okay. Basically, we're done. Now, the only thing I wanted to mention real quick, this is going to be about a minute. When you might see this on your test. What type of slant do we have here? A left or a right slant? It's a right slant. Now, how we set up our first proportion? X over 6. Now, in our other proportion, where's that X going? Top or bottom? Huh? Bottom. X is going on that bottom. Now, what number do we put on the top? Very good. There you go. I just want to show you the setup. You don't have to solve, but I just want you to see the setup because you may get a problem like this on your test. And I know your X is not going to be a perfect number. Because if you do 18 times 6, what do we get when we multiply 18 times 6? I think. Yeah, you're going to get like, X is going to be 10 point something. But the setup is the goal. That's what I want us to worry about. All right. At this point, that is it. Now, we're going to hand back some work before you go.
Where did you see it on?